All right, so in January, we added support for the new verification provider. We added Twilio and Courier. I know we just did Veneer as well. So there's a couple in the woodworks, and at this point, we're probably at 40 to 50 different verification providers. And there's this question going through this and also reading the Standard Webhooks spec and so on that I realized I've been like too afraid to ask for the last 5 years, which is why signatures even matter in the first place. Because when you think about it, the main reason that's being touted out there's both the signatures itself, but there's also the timestamp that has to do with the replay attacks. Mm-hmm. I've always been of the strong opinion that replay attacks were security theater, or at least the timestamps. The main reason being your handling of the webhook should be idempotent, which means it doesn't matter if you get it twice. And the best that you can do with a timestamp is basically give it like a window. It's like 5 minutes. I think the Stripe SDK has a 5-minute window by default, which seems to be more or less what people usually do. So that means like during that 5 minute, it doesn't actually change anything if you're still within that window, which 5 minute pragmatically speaking is more than enough to replay something probably a million times. So already there, it doesn't do much. And second, it leads you to think it's not important for it to be idempotent, while idempotency is almost like a superset of that, where it's going to be important no matter what, because even if an attacker doesn't replay it, the provider will eventually replay it too, because all of webhook delivery is on a at least once basis, which means you're almost guaranteed at some point to get it at least twice. You don't need an attacker for this. And therefore, the timestamp doesn't change anything if you're doing your idempotency correctly. So I tend to think that timestamps complicate the verification, and complicating the verification just makes it more likely that people won't verify, which out there in the wild is a very common thing that people don't verify. So I tend to be of the opinion, make the signature as easy as possible. Make sure they understand idempotency and implement idempotency, because they're going to have to do it anyway. And then the timestamp is not really relevant. But if we bring that logic further, we call APIs billions of times per second with just API keys. What's fundamentally different between an API call and a webhook call? That for some reason, we absolutely need to sign all the webhooks, but not API calls. And I don't know if I have a good understanding of how that came to be in the first place. As much as I know about network security and API security, I genuinely cannot think of a good reason why we're signing. And that, like I said, I've been just like too afraid to ask for the last 5 years.
So I think there's a lot to unpack in what you said. And starting from the concept of the timing of the replay attacks, I think that as a provider and as a large scale provider, you can't look at security as a binary thing where you have one thing or one feature or no feature at all, or like just one set or one verification. You need to look at security, I think. And most providers have done that in the past, where they look at security as a multi-layered thing where you have many layers of protection, so that if one fails, then you go to the next one, then you go to the next one, and you go to the next one, right? And I think replay attacks are that. And you could also talk about JSON web tokens. Generally speaking, I think that they're trying to move towards a standard where we're calling it with a JSON web token, which inherently is a lot more secure than just an API key. And the reason why an API key isn't secure in and by itself is that you're absolutely right. You could do a man-in-the-middle attack in the context of an API or in the context of a webhook. But the danger is that if someone's sniffing your traffic for whatever reason, let's just say that someone gained access to your network and can sniff your traffic. If they start sniffing your SSL traffic, now they have your key. Whereas when you're doing an HMAC verification, you're doing an asymmetric encryption, which means that nobody has the key other than the provider and the sender and the receiver. So anybody intercepting your traffic cannot fake new traffic. They can't craft a new payload because they will need to sign it. And in order to sign it, they need the key, and the key is not in the original payload. So that's the reason why HMAC is actually important. And by extension, the JSON web token. So most of the keys that we send nowadays, if you're doing it state of the art, you're looking at Google, you're looking at whatever, you're looking at some SSO OAuth provider, they're giving you a JSON web token, a JWT. And that's the JWT, that's the bearer token that you're passing. And that bearer token is signed. So depending on the provider, sometimes it's encrypted as well. But it's signed with a key that is also private. So that's why you can't tamper with a JSON Web Token. So you can put all the information. That's the beauty of it. You can put all the information. I can say this thing expires and it's clear. Everybody can see it, but nobody can tamper with it. And the receiver can verify it. And that's completely transparent. So that's where it comes in handy. Well, it comes to integrations and the possibility of Hookdeck being easily adoptable and lowering the barrier to entry as much as possible. And in order to do that, when you start as a small company, you need to be able to support it. After you gain a certain following and you gain a certain recognition in the field, that's when you can start implementing some standards that people are going to start following. But in the meantime, it's up to you, and it's your responsibility as a startup, I think, as a company that's getting into the space, to make it as easy as possible for people to start using. And we want people that receive webhooks through Courier and through Shopify and through all these platforms to actually use us. Therefore, we support receiving webhooks from these platforms, and we make the friction as low as possible.
That's true, but ultimately, at the end of the day, people can still implement their own signatures on top of Hookdeck, right? So Hookdeck doesn't alter the body, it doesn't alter the headers. That means signatures are still valid, and you can still do it the way you've always done, of just verifying your signature. So in that sense, it's a question of adoption. Yes, but I think ultimately the other kind of like well-known thing is that a lot of signatures are not getting verified out there. And when you have a huge disparity of different signature mechanism, because it's not standardized, then it leads to people being lazy or not implementing the signature correctly and all that. So what we did is that we made signatures opt-in, where essentially you can choose to verify with Hookdeck, but it's not mandatory, and then verify a single Hookdeck signature. So what that means is now you have one implementation of signature verification, which is the Hookdeck implementation, and we perform whatever complex signature verification there is on the other end. And now we're all assuming those are hash-based signature verification, but the reality of it is it's like we have a bunch of different providers that are doing asymmetric keys. We have people using basic auth or just like API keys that are not hashing at all. And there's like just a wide range of different implementations of how people built those different signatures. At the end of the day, there's multiple patterns. Like peek behind the curtain, the way that Hookdeck implements signatures is through what we call generic implementations. So we have generic implementations of common patterns. When we add a new provider like Linear, we don't actually do anything then map Linear to our generic implementation. So our generic implementation will take as input the header value, the format, the encoding, and so on. And what we do is we just basically alias it by providing the default site configuration that goes into like our generic implementation. In some case though, like the generic implementation doesn't work because the implementation of the provider is like too custom. And in those cases, then we do what we call a custom verifier. So that verifier will have a specific implementation for that platform that will do whatever fancy thing they're doing. Standard Webhook is this attempt at giving some guideline around what that signature should be. In many ways, I encourage it, and it makes our life at Hookdeck much easier if now we can just have a standard Webhook implementation and not have to deal with all those different disparity. From a user experience standpoint, it's frustrating to get started into Hookdeck, wanting to verify a new platform and not being able to, and then needing to reach the support and then wait for us to implement the verifier. So I'm all for standardization. The thing I do worry about is that the ship is already sailed on that topic, and there's already hundreds of trillions of webhooks going out there that are already using signatures or not standard webhook, and we're like maybe 10 years late where all the biggest platforms are already established, and Twilio is not going to change their signature, and Shopify is not going to change their signature, and GitHub is not going to change their signature. So yeah, sure, you might have one-off like platforms that do use standard webhook or like a standard in general, but ultimately what you end up with is this 2 or 3 providers that are doing this new standard, and then all the other platforms are already established and not doing it, which means at the end of the day, you can't trust the fact they're going to use standard webhooks. So you now need to like go still check their docs and make sure your implementation is correct. And the other thing too is that standard webhook itself is not like super prescriptive, which I think is a good thing, because ultimately like the hope for adoption would be very low if it was too restrictive. But it also means you still need to go check which flavor standard webhook they did, right? It was like symmetric or asymmetric, and how was the payload shape, because the payload is only a recommendation, it's not prescribed in the standard. So ultimately, I wish this would have taken on 10 years ago. I think we should encourage it now, but I'm not keeping my hopes up that tomorrow we won't have to build custom verifiers anymore.
It's a chicken and egg problem too, right? Because if you didn't have that many webhooks, there would be no need for standards, right? So my point is that if you look at history as an indication, you start creating standards when something is widespread enough, or there's a new standard or a new way of doing things. Look at advertising, for instance. We used to have banners of all sizes and all different categories and whatever, and drawings until the Internet Advertising Bureau initiative came about and basically standardized banner sizes that go and show up on ads on websites. But you're absolutely right about the standard. Even if we do get to a point where we have a standard though, like there won't be one standard for a signature. It's going to be an indication. It's going to be a set of algorithms, because there's a very simple reason for that. If I ask you the question, what language is better, JavaScript or PHP? What's your answer? It's the same thing with signature and algorithm verifications. Like there is no one right answer. So it's going to be more of an indication or a prescription of use some asymmetric hashing or something like that. But I don't think you can prescribe it to the point where you're going to say SHA 256 or SHA 512 is what you should be using. Or you know what I mean?
And I think also as a provider, you should probably implement a standard, because you as a new provider that's going to go out there in the market and get like a new set of developers using you and so on, you shouldn't put a burden on people with something that's just completely custom once again. So it's not because as a consumer, you won't be able to just implement a standard that new producers shouldn't then try to do something that's fairly generic or follows the standard. So in that sense, I think it's important to not put the burden on the user. And especially if you do something too custom, then you run the risk of people not verifying at all and so on. So in many ways, I still think it's helpful and relevant for more greenfield projects. One of the big challenges is backward compatibility when it comes to integrations like this. So Standard Webhook itself, they say basically that you can do it backward compatible by adding your old signatures and your new signatures and like different set of headers, which is technically true, but let's be real. Like who's going to want double signatures in their headers for the next decade? Because although you can technically have both in parallel, you have this problem where you can't really remove the old one, or maybe you can, but not without putting significant burden on the developers or building on your platform, right? And I just don't know if producers care enough to like really go to that length. So now you're basically asking people to run two implementations of signatures in parallel, right? Which also increases the surface area for making errors, not verifying correctly, just bugs and so on. So in many ways, I'm not even sure if that's desirable. But for greenfield projects, it definitely seems like a no-brainer. And I definitely encourage everyone. Because one thing that's surprising with Hookdeck is, yeah, we had to implement like custom verifiers and we have this generic that we did and so on. But the reality of it is, it's not that many that don't fit the generic model. We have maybe 15-ish. And when you consider people are using Hookdeck with several hundreds of providers, 15 that don't fit to a generic is really not that big of a deal. So ultimately, I don't know how bad like the breadth of the problem actually is. And in many ways, I think if you're using, sure, like Standard Webhooks and so on, but also tools like Hookdeck, we're also like diminishing like the surface area of the problem. I can't say it's something I'm overly worried about. If you're going to do something new, might as well do it more secure and blah, blah, blah. But the problem is like, where do you draw the line? Because now we're pretty much all doing symmetric encryption. But if you were to follow that logic, why are we not all doing asymmetric encryption? Because it's more secure. So if you follow that logic, asymmetric encryption is more secure than symmetric encryption, because now you're not risking leaking
the private key,
the token, the private key, right? So if you were to follow that logic, why are we doing symmetric keys hashing rather than asymmetric key hashing, right? It's like the same train of thought where it's at some point you draw the line somewhere because of usability, and you find the right balance of it's secure enough, people understand it enough, and it's easy enough to implement that you get to a net outcome that everybody's happy with. And for some reason, it seems like with Webhooks, we landed that symmetric key hashing is that balance. But the history of how we ended up there seems surprising to me, considering it's neither the most secure nor the most usable. It's in this in between where if we were to just do a bearer token or whatever, you would have basically the same kind of security profiles you would with standard API calls that we do all the time. And it would be much more approachable for most developers to implement. And then you have the flip side where it's asymmetric encryption. And even the timestamp adds to that too, because timestamp is like on this gradient of complexity and security as well, right? Where it's at incremental security, which personally I have my opinions on, which I shared earlier. But then there's also the fact that it does make the signature more complicated, because now you can't just verify the payload itself. You need to start concatenating strings together, and you need to get the order right, and you need to get the delimiter right, and you can't introduce a space by accident and all that. The timestamp format needs to be the one that's expected. Standard Webhook recommends Unix and so on. But the point is, you're just adding a ton of complexity for not that much security gain. And why are we there on the spectrum? If the argument was truly security, why are we not doing asymmetric?
Going back to the whole JSON Web Token thing, I think you're right, because we're passing the bearer token, but I think there's a context of the point that I was making earlier, which is you're a caller versus your callee. And when you're a caller and you're passing like a JSON Web Token, the idea behind JSON Web Token is that you're not altering the payload, right? So basically when you pass a JWT, or you pass like basically that bearer token, it's this big string that is encoded and that you encode, that you know how to encode, and that the verifier knows how to validate. And the big idea behind it also is that you don't need a central authorization server to authorize every call. So the clients that you're calling know the logic that they need to run in order to validate that token. But it also means that you're not also, in most cases, encrypting the payload.
You are encrypting it through SSL.
You're encrypting it through SSL, but you're not encrypting it in the same way that you're actually computing a digest from HMAC, right? Where you have a symmetric key between the two parties that is shared. So the callee in that case, in the case of an API, so the receiver is verifying the JSON Web Token and is saying, okay, the JSON Web Token, so basically the key that you passed is valid. But you can't copy it. So someone sitting in the middle cannot copy if that leaks. Like they can't reuse the same JSON Web Token for the next request. Right. Well, they could for a very small amount of time. But I think just maybe is that when webhooks came about, I think the first ever paid webhook that I was exposed to was the IPN. It was PayPal's instant payment notification. And I think because it was dealing with payment, and I think that's where it all started.
Because it's ultimately where you draw the line. As I was saying earlier, what we're doing is already not the most secure option. So what do you value? It has to be this balance of simplicity to security. And if we truly just believed in the most secure possible, we already wouldn't be doing what we're doing right now. We would be doing asymmetric key encryption. And I got the feeling recently that we just all got aboard the verification chain with the SHA-256, HMAC, and whatever. And no one actually asked the question, wait a minute, why are we doing that again? Because Hookdeck is sending HMAC SHA-256 as its signatures, but then we're also just accepting bearer tokens for API, right? And you can do as much damage either way. And there's this one thing that always surprised me, because I remember the very first time I was using webhooks, I wouldn't verify them. And all my developer friends are working like the Shopify ecosystem and so on. Nobody verified their webhook. People just didn't give a crap. But people sure as hell gave an API key when they made an API call. So you're like, okay, what prompted people to not do it? Was it laziness, or is just like it was just a tiny bit more complicated than what they knew, so they didn't really bother to learn it or whatever, right? At some point, I got sensitized to the problem and started verifying everything, and also started working on projects that were meaningful enough to justify it. But I remember having this conversation with Patrick, who was VP of product at Twilio, one of the investor in Hookdeck now, and it was a common, well-known thing at Twilio that most people weren't verifying. Right. And you could tell, because I think there's this one time they broke the signature by accident and a bunch of people just kept accepting the request anyway. So it was like a well understood thing that people weren't really verifying. And obviously it's hard to have any numbers, but ultimately most platforms don't mandate that you verify and they don't check. Right. The only example I can think of is Shopify as this check where there's a webhook that you need to receive if people do a GDPR data removal request. And for that one specific endpoint, they check if you verify. And you need to return the wrong signature, and only if you're an app. So if you're operating, so that is only in the context of you being an app. For most platforms, the challenge is you basically just need to echo a value that's provided in the request itself. But there's a handful of platform where you do need to hash the challenge with a secret key that they give you. But that's very few. I guess like handshake is almost another different topic. But one thing that's interesting actually is that in the standard webhook, they don't even mention handshakes at any point. I remember having that conversation with Okta, as the PM of webhooks at Okta, and were debating whether or not they should have an handshake. Right? I remember that the big concern was that someone could use it as an attack vector for DDoSing. And my argument at the time is that there's way simpler, much cheaper ways of DDoSing than starting to use Okta to subscribe like a bunch of webhook to like whatever arbitrary endpoint, right? But yeah, I think they landed and adding it anyways. I think challenges are in the same vein as verification, where is that same trade-off of security. I guess it's mostly a security from the producer side in this case, but it's a security to usability, right? Because now that means in order to be able to receive a webhook from a platform and even see what a webhook looks like, you need to spin up this endpoint that's going to return whatever's expected from the challenge. That's a huge amount of friction. And I think we have to balance the friction with the benefits that it provides. And the benefit that a challenge provides, at least my understanding of it, is twofold. The first one is that you don't screw up the URL and put the wrong URL and you end up sending your data to someone else by accident, which you would expect that people would notice pretty quickly if that was the case. The second thing is for the producer to not be used as some kind of like attack vector and DDoS. So ultimately, I think as the producer, you gotta weigh how much friction you want to add for your user versus what is actually like the risk there. And I'm a product person. I tend to advocate for less friction. And I do think those kind of security requirements just make it more complicated than need to be, especially with platforms where implementing webhooks is almost a necessity. But you also see that like companies like Stripe, for instance, which I think should in general be taken as an example, do not do challenges, or it's fairly rare in the big scheme of things that people do challenges. So I think like companies that are more developer or DX forward will not implement challenges. And that's something that you can see in the standard webhook spec, for instance, where it's not even referred to once, right? So yeah, that's my opinion on it.
I agree with that one, actually. I think challenges were basically a security measure that we implemented in the beginning and we thought would be a good thing to implement, but it adds so much friction to the process because in a lot of cases also it doesn't necessarily prevent much because you have other layers of protection when you're going to be adding. If you're providing an application that allows you to sign up for hundreds of accounts and then go and add hundreds of URL and these hundred of accounts to go and create a DOS account, your problem is application level. It's not the fact that you're not providing a webhook challenge, right? So my point is the gate should be there before. The gate to protect against a user potentially adding thousands of destinations to some provider and using that as a vector of attack. So yeah, I'm in the same opinion. I think they add a huge amount of friction and they're not anymore as secure as one would tend to think.
Yeah. And on this spectrum, again, of friction to security, right? Even with the challenges, you see the same thing. Because, for instance, Facebook, they'll do a challenge, but they basically just send some arbitrary string that you just return. So ultimately, it doesn't even verify that it's yours, the server. It only verifies that this specific endpoint is expecting this data. That's the only thing it does, right?
No, not really. If you want to break it down even further, it actually verifies that this endpoint can echo data back. That's really the only thing it does.
It's true.
I think also the reason that they do it or that they used to do it is also for timeouts, right? Because you don't want to end up with a bunch of URLs. There is a valid use case where it's not security related. You don't want to end up with a bunch of URLs on your platform that are going to create a situation where your servers have to keep connections open for a very long time. And their way of validating that is basically doing a pre-validation that the URL is actually valid in order not to get into that situation where you might overwhelm your servers with open connections.
There is a difference in expectations between development and production environments. But ultimately, though, the question remains of whose responsibility is this? And I find it hard to justify that it's the producer's responsibility to ensure that you're verifying the signature. The reason why Shopify, for instance, enforces that you verify the signature on the GDPR endpoint is because now they have a legal responsibility that you do, right? But beyond that, they don't. So in a way, as a developer, it feels like being micromanaged, right? To have the producer be like, oh, you're bad, you're not verifying your signature. I'm not sure I want your opinion on this. It's one thing to say that, it's another thing to warn. It's like, hey, by the way, you didn't do this, right? And I think there's maybe a lot more value in educating rather than restricting. And for all you know, there might be a good reason why you're not verifying the signature. For instance, if they're using a platform like Hookdeck, we're not going to return a 400 like status code if the signature is not valid, because as part of our platform, we handle that transparently. And if signature verification fails within Hookdeck itself, but it doesn't fail at the edge or at the response level. And there's multiple genuine reasons why you wouldn't respond the status code right away. So in that sense, I don't know if the provider really should. And the best DX might not be to try to force your users to do anything if it's their own prerogative. That being said, though, tempering down on your expectation and not doing handshake on like developing URLs or like things like that, it's definitely very interesting, but it doesn't necessarily map well to all the product semantics of the different platforms. So for instance, in Stripe, if you're in dev mode or test mode, then yeah, maybe you wouldn't do handshake. Bad example. I probably should have used like Okta or something because they do a handshake. But if the platform doesn't have a concept environment, then you add like a new layer of complexity to the product by saying, well, is this webhook URL dev or not? And you add the cognitive overhead associated with that. So I tend to be of the opinion that it's good to inform, it's good to teach. And most people do a pretty good job at that in their documentation, but I think it's also a community responsibility. And like Hookdeck is playing a part in that with our own guides around signature verification. And you shouldn't try to force the developer to do something that is ultimately their own responsibility.
I mostly agree. I won't lie. The whole conversation made me do it in a completely different kind of dimension where I was imagining something else, but I'll give you a glimpse at that in a second. But I think to solve that problem, you need to have the right tools when you're doing your development, which means that you need to reflect or you need to do what you're going to do in production. And if you don't have that URL yet, then you have a simulator. The call to that URL, whether it's development or production, should be exactly the same from the provider's perspective. And it's up to you as a developer to make sure that you have something that can receive it. And that's where Hookdeck CLI makes things easier. As you were talking, I was thinking that there is maybe a fundamental thing that might happen in the future, that HTTP2 might actually change the way that all this works. I'll explain myself. WebSockets were born as a shortcoming of HTTP1, right? Where you can upgrade a transport, and it was an afterthought of HTTP1. With HTTP2, it's basically baked in. Stateful connections in HTTP2 are baked in. And why not imagine a world where you can delegate all this verification stuff to the transport itself, which is HTTP2, and have stateful connections, and say that if this guy establishes a connection and authenticates with me, then I use that communication channel. And I think we're talking about standardization of webhooks, and I think that's the next evolution, and that's where it's going to go. In order for something so established to be replaced, you've got to replace it with something better. And that, to me, is the better that it could someday be replaced with. The that's better, really, to me, is HTTP2. Yeah.
Love it.